Hi, we are part of the Biomedical Engineering Senior Design Team assigned to the clinical blood clot testing device sponsored by Boston Scientific. I'm Eleanor.
I'm Sloan.
And I'm Gonzalez.
So a huge part of this project is blood clots. Blood clots are essential to life as they stop blood from leaving vessels after an injury. However, they can be deadly if they become dislodged from where they were once located into a smaller vessel and block the blood flow through that vessel. This can lead to organ damage, stroke, or even death if they are not treated promptly. So the way that they are treated is through thrombectomy devices. These are threaded through the femoral artery via a catheter to where the clot is located, and then suction is used to suction out that blood clot. And then that blood clot is collected in a collection filter that filters out the clot in the blood, and that clot can be extracted and tested.
The goal of this project is to characterize blood clots further. As we mentioned, this project is partnered with Boston Scientific. They work with a variety of cardiovascular devices such as heart valves, stents, angiojet systems, and catheters. They want to test their devices at earlier phases in development, and that requires a synthetic blood clot material that models the in vivo properties we see of blood clots in vessels. Understanding an amorphous or a non-crystalline material such as a blood clot is very difficult when looking at conventional mechanical testing methods. The blood clot is composed of red blood cells, a 3D fibrin network, collagen, and elastin. It also has a clot contraction phenomenon that occurs in the blood vessel, condensing that fibrin network and changing the mechanical properties drastically.
The left image is the side view of our prototype, which we use to test the blood clots. As the motor spins in one direction, the rod also spins in the same direction, moving the force gauge down onto the test chamber. The pinda will also move down until it detects the metal sheet. Once the metal sheet is detected, the whole system will move in reverse, taking the force gauge out of the test chamber. The force gauge is aligned with the test chamber right there. Then we have the test chamber base and the test chamber holder, which both can be removed for sanitization, and the tip on the force gauge can also be removed. The way our testing device works is we have the compressor, which moves down onto the blood clot within the tube walls. Blood clots have a serum, so in order to effectively test the blood clots, we need to remove the serum using a porous material. So as the compressor moves down onto the blood clot, the serum will be seeped out into the porous material. Like that, we are not testing the incompressible properties of the liquid. And this video shows how the porous material is absorbing the serum as the force gauge is moving down onto the blood clot.
Thank you for listening to our video. We look forward to answering your questions at the Presentation and Design Expo.